Hey everyone, this is a short video going over the Lab 2 contents. This lab introduces some of the fundamental protocols you need to learn for this class, being I2C, which we use for a lot of our peripherals, and SPI, which is used for higher speed transmissions. The outline for this lab is that we must write our basic I2C functions, our single writes, our single reads, our multiple writes, multiple reads, and then use these functions and wrap them around in device drivers that do a write for our IMU and our photo sensor. Important considerations when writing some of these basic I2C functions are: which I2C module do we want to write to? Do we know the address of it? Do we have access to it in a macro defined in one of the headers? Please look through the headers that are provided. Those are one of the important parts of templating that we give you. However, you can look for the datasheets for these online and find plenty of the defines in there as well. There have many controllers for these devices on the boards. A lot of cases there may be multiple I2C modules. We need to know which module we're going to write to. Do we need to use GPIO pins to write to it? Hint, pretty much always. We need to configure these pins to a certain mode, perhaps. An understanding of our I2C interface, we need our addressed reads and our addressed writes. So we want to write something to an I2C module. Which I2C module do we want to write to? Which one do we want to read to? Which bus? Which module? Where do we want to write it? So we need to perhaps send a data address first. What data do we want to write? So we need to send some data to follow. Is there a certain mode we wish to send this in, burst or single mode? And then the important part is to always await the data busy flag or the bus busy flag afterwards, so that we can know that the transmission has finished. For the multiples, the other extra piece is how we will handle multiple data bits. We might pass in an argument for how many characters are in a string for something that we wish to pass, or however many pixels in a line that we wish to pass. For the BMI inits and the optometer emits, these are fairly simple for I2C. Again, you will write to some configuration registers, so you must specify the address of the memory mapped register in the device, and then you will pass the data for the configuration profile that you wish to pass into it. These are rather simple. These will mostly be wrapped. It will look something like you will power it on in its init functions, and then you need to write to an address, write a configuration profile to that address for a few of the pieces. If you want data out of our device, which address do we need to access for its output data registers? Does it have an address? Do we need to wait busy after we've finished? Those are the main things to consider here. Part B is outputting sensor data with UART. We've used UART in lab 1 already. SPI init, so we need to write our basic SPI functions, and then we need to go and configure our SPI device. SPI inits are a little longer than I2C inits. However, the main point of contention is that the configuration for a SPI device is much longer. SPI devices are much faster, so there are a lot more configuration options for them. Naturally, with the SPI inits, we need to know which one we're going to write to, so which SPI module. There are many modules normally between faster, slower QSPI modules. We need to know if we're going to use GPIO pins. Hint, of course we are. If we're going to use a chip select pin. In micro P1, we came across multiple pins that had different functions, so we need to tell that pin if it's what it's acting as. Chip selects are important because I believe that the SPI pins overlap with some of the pulse width modulator pins. So if you, for example, write to a pulse width modulator while you're using the screen, you may accidentally write data to the SPI screen, and that may cause an error or break your screen potentially. There may be profile pins, as in power profile pins, and the important part is the command data configuration option. When you're sending SPI information to a SPI module device, you need to know if it's a command for configuration, or you need to know if it is some data that we are sending to it. So that is references our DS pin. You can find more in the headers and in the unknown documentation for that. Please use the headers. Again, this is a large part of the templating that we give you, and it is very helpful instead of digging around for addresses of configuration devices that you do not need. The behavior functions for it, mainly we're going to select, so we're going to use the chip select, enable it. These are active load generally, so select the device, so we are using it. We need to set the window, so we center where we're making our writes. we need to write some data using our SPI write functions. So that's in the data transmission mode. We write some data to it, maybe some pixels, and then we're going to deselect the device. And that is the general loop for how a SPI write happens. You are going to use what are called our GFX libraries, our graphics provided libraries. These will source from a lookup table for a font, and you will use those to output some data to the LCD display of what we just did in this. So part B was using Neor to output it. For this one, we want you to write it to the SPI screen. The data should already be formatted from part B. The SPI screen should be simply copy and pasting a little bit over from the GFX libraries or editing some of the functions because they're using an older syntax and our modern compilers do not support it. The extra credit is based on timers. You must implement the timer counters. There are timer counter modules present on the board, obviously. We must configure those, we must enable them. We must set them to point to something, whether or not they're going to be an interrupt. We must enable the levels of interrupt. If you want it to be a low level interrupt, we would need to turn off interrupts first to enable all of the configuration options. We need to set global interrupts last. We also need to use our interrupt vectors. The big important part is setting where our interrupt vector points to. So when an interrupt happens, we need to execute a handler of some sort. That is done in the project properties file. And that is simply the bonus extra credit. We'll give you plenty of points for that. Other than that, good luck on the lab, and thanks.